A single finished cartridge represents a remarkable journey of industrial precision, transforming raw materials into a reliable tool in minutes. Many people who handle ammunition sporting professional personal use often wonder about the intricate process. Not a simple, craft, highly automated, meticulously controlled manufacturing sequence. The path begins with large quantities of metal brass lead chemical compounds. These base components will undergo dramatic transformations shaped by immense pressure, heat, and precise machinery. The cartridge case is arguably the most complex component to manufacture, and its creation begins with a large spool of brass sheeting or a collection of brass cups. A machine called a blanking press punches out thousands perfectly circular discs from the brass sheet. These discs are the first rudimentary form of the case. They are then fed into a cupping press, which uses a powerful punch and die to shape the flat disc into a shallow cup. These shallow cups are then moved to a transfer press. The cups are forced through progressively smaller dies. Draw 1, draw 2, draw 3. Each draw elongates the cup, making it taller and thinner until it resembles the final cartridge case. This process work hardens the brass, making it strong and durable. To prevent the brass from becoming too brittle and cracking, it is often annealed between draws, heated to a specific temperature, then cooled. After the case has been drawn to its required length, a trimming machine cuts the mouth to a precise, uniform length. Next, the base of the case is formed. A powerful header or bunter flattens the base, forms the extractor groove or rim, and creates the primer pocket. The head stamp is also imprinted, showing caliber and manufacturer. Parallel to the case manufacturing line, another process is underway to create the projectile, or the bullet itself. The most common type of bullet starts as a thick spool of lead wire. A machine unspools this wire and feeds it into a powerful press that performs a process called swaging. The machine precisely cuts a short segment of the lead wire, then uses a die to compress it into a basic cylindrical shape known as a core. The weight of this core is incredibly important as it directly affects the ballistic performance of the finished round, so the machine is calibrated to cut exacting lengths of wire. For jacketed bullets, full metal jacket, jacketed hollow point, a second component is needed: the jacket. This jacket is typically made from a copper alloy or gilding metal. A press punches out discs and forms them into shallow cups. These cups are then drawn into the shape of a thin-walled cylinder, open at one end. The next stage involves bringing the lead core and the copper jacket together. The lead core is inserted into the open end of the jacket. Specialized dies seat the core and form the final shape of the bullet: pointed spitzer, round nose, or hollow point. The pressure effectively fuses the lead and copper into a single, solid projectile. After forming, bullets are polished and inspected for weight, diameter, length, and overall form. While the metallic components are being shaped, the energetic materials, the primer and the propellant, are carefully prepared. The primer is a small self-contained component that acts as the initiator for the cartridge. This machine carefully dispenses a wet, paste-like priming compound into the cup. This compound is a highly sensitive primary explosive designed to detonate from the sharp impact of a firing pin. Safety is paramount here. Operations done in isolated cells, behind blast shields, using remote controls. Once the wet compound is in the cup, a small piece of paper and a thin foil are placed over it. An anvil is inserted, a small tripod-like metal piece. The assembly is pressed together, then left to dry in a controlled environment. The drying process is critical. Any residual moisture can render the primer inert. After drying, primers are tested for sensitivity, reliable detonation from a standard firing pin strike, yet stable for handling and loading. The propellant, or smokeless powder, is manufactured in a specialized chemical plant, often separate from the ammunition factory. It is a nitrocellulose-based substance created through a complex chemical process. The final product is formed into small granules, flakes, flattened balls, extruded tubes. Each shape burns at a different rate. Burn rate determines the pressure curve inside the barrel when the cartridge is fired. At the factory, powder is stored in climate-controlled bunkers and handled with extreme care. Each batch is test-fired to match pressure and velocity so new lots perform identically to previous batches. The final stage brings all the meticulously crafted components together on a high-speed automated loading press. First, a finished and inspected case is fed into the line. The first station ensures the case is correctly oriented and checks the primer pocket. A primer is carefully seated into the primer pocket. Sensors confirm it is present and flush. Next, a precise charge of tested propellant is dropped via volumetric or weight-based systems to ensure exact fills. A check station verifies the powder level. Any incorrect charge is ejected immediately. A bullet is fed from a hopper and oriented correctly by the feed system. Then it is pressed into the case mouth to a specific depth, a critical dimension for pressure and accuracy. Immediately after seating, the case mouth is crimped to secure the bullet and regulate initial pressure buildup. The finished cartridge now looks identical to the millions produced alongside it. Completed rounds undergo a last battery of inspections: overall length, case dimensions, and primer seating. Samples are fired in test barrels to confirm velocity and pressure. After passing this final gate, machines count rounds into boxes, seal them and label them. The label shows the caliber, the bullet type, and the lot number, vital for tracing any batch back through the process, completing the journey from raw metal to a safe, reliable, finished round. So, let's get into it.